This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to the discussion. Today, we'll be delving into a research paper titled No Imputation Without Representation, which investigates the effectiveness of incorporating missing value indicators alongside various imputation strategies in machine learning classification tasks. What are the core arguments presented in this paper regarding the handling of missing data?
The paper challenges the common practice of solely using imputation to handle missing values in datasets. While imputation creates complete datasets suitable for algorithms that can't handle missing data, it potentially discards valuable information inherent in the missingness itself. The central thesis is that representing missing values explicitly, using missing value indicators, can improve classification performance.
The paper mentions different theoretical perspectives on the benefits of missing value indicators. Can you elaborate on these conflicting viewpoints?
One perspective suggests that adding missing value indicators increases data dimensionality, potentially improving model representation. Conversely, omitting them acts as dimensionality reduction, potentially enhancing efficiency by removing redundancy. The informativeness of missing values is crucial. If they're missing completely at random, MCAR, or missing at random, Einarm indicators might not be beneficial. However, if they're missing not at random, MNAR, indicators could capture crucial information.
The paper highlights a lack of large-scale empirical studies on real-world data sets. What was the scope of their experimental design to address this gap?
The authors conducted a comprehensive experiment using 20 real-world data sets with naturally occurring missing values. They evaluated 3 imputation methods, mean mode, nearest neighbor, and iterative imputation, with and without missing value indicators across a range of popular classification algorithms. This allowed for a robust comparison of different approaches.
What were the key findings regarding the impact of missing value indicators on classification performance?
The results generally showed that missing value indicators improved classification performance across most algorithms. A notable exception was CART, classification and regression trees, where overfitting was observed without pruning. Interestingly, more sophisticated imputation methods, nearest neighbor and iterative, didn't consistently outperform simple mean mode imputation when combined with missing value indicators.
The paper suggests a safe default approach. What constitutes this default, and under what circumstances might it be less suitable?
The recommended default is using mean mode imputation with star missing value indicators. This is because it's simple, widely applicable, and generally effective. However, this approach might be less suitable for algorithms with built-in missing value handling, or when missingness is demonstrably MCR or MAR. Also, pruning is crucial for tree-based models like CART to prevent overfitting.
The study also explored the relationship between the amount of missing data and the effectiveness of missing value indicators. What insights did they gain?
They found that the number of missing values, both absolute and relative, often positively correlated with the benefit of using missing value indicators. This aligns with the intuition that more missing data provides more information to learn from. Interestingly, the benefit was generally greater for categorical attributes than numerical ones.
Can you elaborate on why missing value indicators might be more beneficial for categorical than numerical attributes?
The paper suggests that mode imputation for categorical variables renders missing values indistinguishable from existing values, whereas mean imputation for numerical variables creates a new artificial value. This artificial value might still retain some information about the missingness, reducing the benefit of explicitly representing it with an indicator.
The paper mentions an additional experiment involving the order of imputation and one-hot encoding for categorical variables. What were the results of this experiment?
They compared mode imputation directly on categorical variables versus mean imputation after one-hot encoding. Without missing value indicators, mean imputation after one-hot encoding sometimes improved performance. However, the difference was less pronounced when missing value indicators were included.
The authors provide recommendations for practitioners. Can you summarize these key takeaways?
The main takeaway is that mean mode imputation with missing value indicators is a robust and generally effective default approach for handling missing data and classification. However, practitioners should consider the specific algorithm used, the nature of missingness, MCR, MAR, MNAR, and potential overfitting or underfitting issues. Dimensionality reduction techniques can also be beneficial in conjunction with missing value indicators.
The paper mentions several previous studies on missing data handling. How does this research build upon and differ from prior work?
Previous studies often lacked the scale and scope of this research. Many used limited data sets, artificially introduced missing values, assuming MPRR, or didn't compare the same imputation strategies with and without indicators. This paper's use of 20 real-world data sets with naturally occurring missing values provides a more robust and generalizable assessment.
The paper focuses on classification. Do you think the findings are transferable to other machine learning tasks, such as regression?
While the paper focuses on classification, the core principle that missingness can be informative is applicable to other machine learning tasks, including regression. However, the specific optimal imputation strategy and the impact of missing value indicators might vary depending on the task and the model used. Further research is needed to explore this.
What are some limitations of this study, and what avenues for future research do you see?
One limitation is the reliance on a specific set of datasets and algorithms. Future research could explore a broader range of datasets and algorithms, including those with built-in missing value handling. Investigating the interaction between missing value indicators and different dimensionality reduction techniques would also be valuable. Finally, extending the analysis to other machine learning tasks beyond classification is crucial.
The paper concludes that the combination of mean mode imputation with missing value indicators is a safe default. However, are there any situations where this might not be the best approach?
Yes, there are situations where this default might not be optimal. For instance, if you have strong prior knowledge suggesting MKR or MAR data, then the added complexity of missing value indicators might not be justified. Also, some algorithms are specifically designed to handle missing data effectively, rendering imputation and indicators unnecessary. The choice should always be data-driven and informed by the specific context.
The paper emphasizes the importance of considering the informativeness of missing values. How can practitioners assess this informativeness in practice?
Assessing the informativeness of missing values is challenging. There's no single definitive method. However, domain expertise is crucial. Understanding the data generation process and the reasons for missingness can provide valuable insights. Statistical tests, such as those for MSRAR and MAR, can be helpful, but they often rely on strong assumptions that may not hold in real-world scenarios.
The paper uses AURC as a performance metric. Are there other metrics that could be used to evaluate the effectiveness of missing data handling techniques?
Yes, AURC is just one metric. Other relevant metrics include accuracy, precision, recall, F1 score, and AUCPR, area under the precision recall curve. The choice of metric depends on the specific problem and the relative importance of different types of errors, false positives versus false negatives. A comprehensive evaluation should consider multiple metrics.
The paper mentions the scikit-learn library. How easy is it to implement the proposed methods using this library?
Scikit-learn provides tools for various imputation methods, but implementing missing value indicators requires some manual data manipulation. However, it's relatively straightforward to add indicator columns to the dataset before applying the chosen imputation and classification algorithms. The paper's authors provide code to facilitate this process.
The study uses standardization for numerical attributes and one-hot encoding for categorical attributes. Are these pre-processing steps always necessary, or are there situations where they might not be beneficial?
Standardization and one-hot encoding are common pre-processing steps, but their necessity depends on the specific algorithm and dataset. Some algorithms are sensitive to feature scaling, while others are not. Similarly, one-hot encoding can lead to high dimensionality, which might be problematic for some models. Experimentation and careful consideration of the algorithm's properties are key.
The paper mentions the use of the Wilcoxon signed rank test for statistical comparison. Why was this test chosen, and are there alternative statistical tests that could be used?
The Wilcoxon signed rank test is a non-parametric test suitable for comparing paired samples, which is appropriate for the experimental design in this paper. Alternative non-parametric tests include the sign test, while parametric tests like the paired tat test could be used if the data meets the necessary assumptions. The choice of test depends on the data distribution and the research question.
The paper's findings suggest that the choice of imputation method is less critical than the inclusion of missing value indicators. Does this imply that imputation research is less important?
No, imputation research remains crucial. While this paper highlights the importance of missing value indicators, the choice of imputation method still affects the quality of the imputed data and can influence the final model's performance. The optimal imputation strategy might depend on the specific dataset, the type of missingness, and the chosen classification algorithm. Further research is needed to better understand these interactions.
This has been a thorough discussion of the paper's key findings and implications. Thank you.